Hey Joel, how's it going? Can you hear me all right? Awesome. Okay, can you guys hear me? Can you just drop in the chat if you can hear me all right? I want to make sure before I start recording here. Awesome. Thanks, Trevor. We will just wait a few more minutes here until the rest of your classmates get in. Here comes Hunter. While you guys are waiting, you probably noticed that I just uploaded a bunch of stuff on Canvas. So what I've done for this week is because both Lab 6 and 7 were pretty short, I combined them into one day. So if you want to go ahead and go to that Lab 6 and 7 file and start downloading the CSVs and the R code so that that's ready to go, then we can get rolling. Let's see, we got 6 of you here. I know Audra said she was going to make it, so I'll wait just a little bit longer. How'd presentations go? Hey, Billy.
Internets, but relatively good.
Okay, awesome. Let's see here. Okay, so we got 7, getting closer. I'll give everybody just 2 more minutes here and then we'll get rolling. Did everyone have a good Thanksgiving weekend? Anyone do anything cool? Go fishing, shoot any animals, play football, that kind of thing?
I went hunting the week before.
Nice. You get anything?
Yeah, I got a 10-point buck up in Nebraska.
Bravo.
It was the biggest one I've ever got, so it was nice.
Right on. That's awesome. All right. Okay, we got Audra. I don't know if Lana will be joining us or Justine today, so we'll probably go ahead and get rolling. But yeah, I mentioned earlier to some of the folks that had joined that we're going to be doing a combined lab today for Lab 6 and 7. Both of them were pretty short in terms of the R code and Excel work, and so I figured we'd just kind of condense them into one lab. And if we finish up and you guys have like put together your report again in that Word document, you can go ahead and email it to me at the end of lab today or later tonight, and I'll go ahead and get that grade entered for you. So my intention was that you wouldn't have any outside activities for today, since you've got a quiz to do over the guest lecture and then your pond reports. So that's kind of what I wanted you to focus on for the next week ahead. First off, does anybody have questions over the quiz? Did you guys see that I posted like review notes from Ernie's lecture for that? So this one's on Canvas. And it's just 10 points. It's like 5 questions or something like that. 2 points each. Everybody see that? We get a thumbs up or a yes in the chat. Okay, thanks, Audra. Okay, good deal, good deal. So yeah, be sure you take that tonight before midnight to finish that out. Shouldn't take you more than like 30 minutes max to get through those questions. I made them pretty straightforward if you're paying attention, or if you go back through those notes as a little brush up, that can really help. Okay, let's see. So I'm actually going to start today by going through like kind of what Keith and I talked about for finishing up the end of the semester. So after I was home and delayed by COVID, I was really bummed that I couldn't join you guys at the river because I heard you caught a sturgeon. And sturgeon are actually like my favorite fishes. So I'm very jealous. And I had serious FOMO when you guys were out there. That was the lab I was most looking forward to for the semester. But I'm glad you guys had a chance one last time to get together and go out there and sample. Yeah, I'm sorry I didn't get to do that in person with you guys, but COVID sucks. So we'll go ahead and just kind of go through the expectations for the pond report. So you can see I just uploaded this document. Let's see here if I can share my screen. There we go. Okay, can you guys see that now? Sweet. Okay, so this is the pond report that'll be due next week, next Monday at midnight. And so kind of like I explained to those of you that were in class 2-3 weeks ago now, here's the scoring rubric. So the whole idea of it is to kind of synthesize all of the work that we've been doing over the course of the semester and put that together in a little bit of a case study for the data that we collected together at the Tallgrass Preserve. And so there should be, I think in Canvas, there should be that file that I uploaded that has diet data and like length, weight, and age data for all of these bass now that we've calculated together. And if you guys have any questions about this at any point this week, you can go ahead and email me. I only ask that you don't like plagiarize one another's work, let's like abide by the honor code with this. And so basically it's going to be a rundown of each of these components will be worth 2 points. And so I want to see a length weight relationship, a pop estimate with confidence intervals, your CPUE and PSDs, a condition. I want to see calculating an index of relative importance and the proportional similarity index, including your tables for those calculations, as well as a catch curve, which we're going to practice today, and that plot of a mean back calculated length at age. And then you'll have 2 points for including your management recommendations, whether or not you recommend some kind of bag limit or a protected slot, some kind of minimum length limit, whatever it may be. I want to see that you can argue using your data to make a case as to why you think the pond should be managed that way. And then just 2 points for general formatting and clarity, having a clear kind of introduction to the pond. I want just like a paragraph description of the pond itself and what prompted the report, and then a paragraph of your methods. So what did we do when we went out and we mark recaptured, like tagged the fish. You can say we just used hook and line sampling, right? Because we were just fishing for all these fish. And then you're going to have a written results and discussion section that is probably going to be multiple paragraphs, and then as well as your figures. So I'm guessing you'll have probably like 2 pages of written text max, and then several pages of all of your figures and tables at the end of it. So the whole goal is to give me a cohesive report, right? To give me a professional looking summary of all of the data that we've collected from this impoundment and your argument as to how we should manage it. So does anybody have any questions right away about the components of this, expectations? Just drop it in the chat or pop on here. No? Okay. Well, if you do have any questions throughout the week, please let me know. If you want me to read over something before the final draft is due, please get it to me by this Friday. So I have the weekend to read it and get something back to you by Sunday so you can like work on it. But yeah, should be pretty straightforward based on all of the code and labs that we've done throughout the semester. Okay, so that's the pond report. Oh, sorry, Andrew's got something.
So it did say, oh wait, never mind. It said on Canvas it was due the 14th, but
Yes, That's been updated. Yes, sorry about that. Okay. Any other questions? No? Okay, awesome. So now you guys can go ahead and open up lab 6 and 7. So we're going to start with age, growth, and mortality. I'll share my screen again here. Okay, here we go. So we're going to go ahead and use data collected in 2018 to determine the age and back calculate length and age using a software package in R called rfishbc. And so this is how we're going to make that back calculated length and age plot. And so we'll be using 2018 data for this practice example, and then you guys will use the table that's in Canvas with our data from 2020 to do your calculations. All right, so let's go ahead and pull up our code. Looks like I need to reinstall my Fish RBC, so I'm going to go ahead and share my R screen here if I can. Okay. So yeah, my R is still reinstalling all of this stuff again. I need to go ahead and get all of my downloads out of here too. All right. You guys don't have to stay muted, by the way. It's actually like really weird for me to just be like silent on here. Just, I think Keith comments on that too. I've heard we've got such a small class. Like I don't care if I hear you guys in the background. No need to be embarrassed here. Okay, let's see if this is going to allow me to get through this. All right, so we're going to go ahead and install the necessary packages. So now I need to reinstall some of these. If you guys haven't used Tidyverse before, Tidyverse is like a great package. It's kind of like a collection of packages, and all of the Tidy tools are tools in R that allow you to kind of like clean up data frames, subset data frames, and just like arrange all of your factors and data frames in a more synthesized manner. There's a lot of great like concatenating tools and different tools that allow for tidy data management, hence the name. Okay, so let's see here. I'm going to go ahead and I think I've got the right working directory for these guys. Let's see if this opens up. Yep. Okay. So we're going to go ahead, set our working directories, and then bring in this file, this JDK BCN, the annuli data from these otoliths that Ben processed. And so now we're going to create a vector of TIFF files in a working directory. No files have a TIFF extension. Oh, this is fun. Okay. Is that going to work? BGHR images not found. Okay, let's see here. Ah, this is probably why. We've got JPEGs. So it looks like TPNP otoliths. We've got RDS files and JPEG files, not TIFF files. This is interesting. Okay. I was really hoping I could get this to work on this computer. I got it to work on my laptop last night. Now I'm not exactly sure. Let's see here. When you guys downloaded your zip files, did you guys get, let's see here. Did you guys get like TIFF files or JPEGs? What was in this original? Looks like they were all JPEGs, right?
I have JPEGs and RDS files.
Okay, so you're not the only one. Okay, let's see here. So let's change TIFF to JPEG and see if that runs. No files have a JPEG extension. PGHR, desktop, LNB otoliths. Yeah, I definitely have JPEGs and RDS files for everything. Let's try RDS, see if that works in the code. Did anybody get it to run when they changed it to JPEG?
I got the same error that you did.
You did? Okay. Curious why it says no files have a... Interesting. All right, well, this might not actually work here. Export list. Okay, so this actually, all of these pieces of code were just what was being used to get this BGHR, BCL, XLSX table. And so I was going to try to show you guys, Hunter got to do a little bit of this, where this program, basically you load in a bunch of JPEGs or TIFF files, like images of otoliths, and you go through and you manually set the foci, and you can click along each annuli, and then it calculates all of these values. It'll back calculate ages for you automatically. And so it's a really slick software, basically, to allow you to point and click really quickly through and do aging in R. So we won't be able to do that together, but we do have this summary data here. Okay, let's see. I always forget that I need to like reshare multiple different screens. Okay. How about you guys join me in looking at this spreadsheet right here? And so to kind of orient you to what we're looking at, these are fish IDs, right, from the same impoundment. I don't know what BGHR stands for, but I assume it's a small impoundment somewhere here in Kansas. So we've got a bunch of largemouth bass that were collected in 2018. We've got our total lengths. We don't have weights for all of them, but they evaluated sex for all of them. They had 2 consensus readers that were aging. These values were the age at capture estimates based on their otolith readings, and then these are the back calculated length at ages. So you see the vast majority of them are age 1 bass, and so there's not a lot of back calculated lengths here, but these few down at the bottom, we see this fish was 4 years old, so they've back calculated what it would have been at length 1, length 2, length 3, using those von Bertalanffy growth equations. Okay, so I'm going to stop sharing this. And so basically, the first section is that we want to create a line graph in Excel or R showing the mean total length at age for each BAS from the TPNP data set. So why don't we actually like use our TPNP data together? That way we can get some practice together on data that we have collected and know a little bit more intimately. And you guys, if we use them for lab today, then that's one less thing that you guys have to calculate for your reports. Sound good? If I can find the file. No, I had them in here. If not, I can re-upload them. Okay, so here were the lengths and weights for everybody. And then we had ages. Man, where did those go? If anyone finds it in in Canvas faster than I do, please let me know. So sorry, I had it uploaded in there. That's why I don't understand where it went. Okay, so this is the 2016 stuff. Anybody having any luck on Canvas?
What are you looking for again?
So I'm looking for, I uploaded a few weeks back after we finished our aging and our diet labs, I uploaded the summary. There was a Excel file, an XLSX file with all of the summarized data for our tallgrass bass. And I'm not exactly sure where they all went. Like if it got accidentally moved to a weird location in here.
Like what was found inside the stomachs?
Yep, it was a single database that had not just what was in the stomachs, like all of our food habits calculations, but also the aging. Because I had entered all of your guys' ages when the 7 of us in lab went through one by one, and you guys wrote out on your different little sheets of paper like what the ages were. I had all of those. I'm gonna pull up my laptop.
I think I found it.
Do you know what subfile or folder you found it in?
If you just go to files, it's the second to last Excel file, or like second to last folder on there.
'Cause I entered all of your guys' ages because I entered all of your guys' ages when we did the 7 of us in lab went through one by one, and you guys wrote out on your different little sheets of paper like what the ages were. I had all of those. I'm gonna pull up my laptop.
Or like second to last folder on there. the tallgrass lab bass.
Oh, sweet Neptune. There it is. Thank you so much. Wow. I was losing my marbles, guys. I was about to have a conniption. I could have sworn I had those in here.
Is this the tall grass? It's like length, weight, otolith ID.
Yes.
Is that the one?
Bingo. Yes. All right. Thank you. Thank you for keeping me sane, everybody. I appreciate it. So I'm going to go ahead and share this one. So this is what I put together from what we did as a class. And so basically for the otoliths, I went through and there were 6 of you. I didn't include mine for the aging. And then we had a mean age. And so I included all of the age estimates for everybody so that we have the variation for confidence intervals. And so we've got each of the otolith IDs from the board that Hunter helped us epoxy, and then the length and weights. And we also have those same corresponding length and weights for the diet data. So let's see here. So let's go ahead and use these length, weight, and mean length at age data for this first activity. Let's make a figure 1. So a mean back calculated total length versus age. So this will be that the mean column in that spreadsheet that I just showed you based on the consensus aging. So I'm going to give you guys just a couple minutes in Excel to put that together, and then I'll just ask one of you guys randomly to share if anybody's willing to share one of those. But basically, we're trying to create an Excel graph that would look like this. All right, I'm going to stop.
What were the parameters of the figure we're making? It was mean against what?
Yeah, so it's the mean length at age against these back calculated total lengths. So if you go back to lab 6 and 7, the Word document, that first, the first figure 1 is the example that I want you guys to replicate, but with the tallgrass data. All right, how's everybody doing?
Don't know if I did this right.
Do you want to go ahead and share your screen so we can see?
So are we just making so we just made a graph comparing the mean to the length?
Yep.
Mean age.
Yep. And then for your error estimates, so basically I just calculated, I added a column next to the mean, and then I added another column for my standard error. And so I just did equals standard deviation and then selected for each row, I selected A1 through A6 values, and that's your standard deviation. And then your standard error, right, is your standard deviation divided by the square root of the count of how many different columns you had. And so let's see what you got, and then I'll show you mine.
I didn't do a pivot table, so I think that's where I went wrong.
Okay, that's fine.
So I think I just need to restart and do that.
Okay. Anybody else? How's everyone else doing? Does anybody remember the trick in Excel to quickly swap your X and Y for your like data? It's on the data. Thank you. Where on this tab can I find it? In the data section? Oh, sweet. Oh, there we go. Okay. There we go. There we go. Okay, cool. All right, let me go ahead and share my screen here. Okay, so I definitely need to adjust the scale on this chart. But basically this would be your mean length, right? Or sorry, this is age. Wow. Okay. So that's your back calculated age. And then this is your length in millimeters, right? Everybody kind of see that? And then those error bars, we see we have a pretty wide range for error for a little bit of this. One of those lines, these horizontal, just disregard the horizontal ones for now. I would need to go back through and delete those. But basically, you see these columns where I calculated first my standard deviation, and then from that, my standard error for each of the rows here, for each of the otoliths individually. Does that make sense? All right, thumbs up if that kind of makes sense. Thumbs up if that was okay. Thank you for the thumbs up. I appreciate it. Okay. So basically, a cleaned up version of this plot is what I'll want for one of the components of your report. And so this will be that figure. Okay, so now as a group, let's go through and answer these discussion questions. So the first question, does the growth rate differ among the age classes? And so you're supposed to speculate about ecological reasons that might explain any differences. And then it asks, would you expect the growth rate in terms of total length to increase, decrease, or remain constant throughout the life of a fish? Who has any thoughts? So what do we kind of see? We've got two general groups of ages for these fish, right? What are the two general groups?
It's like year 1 to 2, and then another year 3 to 4, and then like some like 1 maybe between 5 and 6.
Bingo. Yep. Thanks, Aaron. So we've got this group here of 1 or 2-ish year old fish, and then we've got several that are 3 or 4, and then one slightly older one. And so, so the question's asking, does the growth rate differ among age classes? And so among that, we see with these ages a variety of lengths. So what does that tell us if we've got some variation? Does that mean, yes, there is variation in growth rates within the same age classes?
Yes.
Yes, yes. And which of these two groups shows greater variation in growth rates?
1 to 2.
The 1 to 2, very good. Yeah, so we see that there's much less variation in growth rates for these age 3 and age 4 fish. All right, and then would you expect growth rate in terms of total length to decrease, increase, or remain constant throughout the life of a fish? Keith talked about determinate versus indeterminate growth in lecture, right? So how are fish different, generally different than humans in terms of their growth? Anybody remember? So fish generally grow throughout their lifespan, right? So even really old fish are growing a little bit each year. So they generally, most species demonstrate a degree of indeterminate growth. So even really, really old and largemouth bass would continue to grow in length just a little bit each year for older ages. So this is general, and different species of fishes like vary in their degrees to which they continue growing after they reach maturity. For a lot of fishes, they increase more in condition or weight, right, instead of length, but they are still generally increasing in length throughout the lifespan. So we're not expecting the length of a fish to remain constant throughout its life. Then